Welcome to video lecture number 5, our last video for this unit. You've learned quite a bit about the arrangement of the periodic table of elements. In this video, we'll put all the different pieces together to describe the physical and chemical properties of elements according to their placement on the periodic table. Let's start by reviewing all of the different ways we've learned to describe an element on the periodic table. We know that each element under a group number with a digit and the letter A are called main group elements. The ones with a B are the transition metals. The group number above each main group element represents the number of valence electrons an atom of that element has, which also determines its reactivity. The period number, the ones off to the left, represent the number of energy levels that that element's electron cloud has. Whether an atom of an element gives valence electrons in a chemical reaction or not is also determined by its placement on the periodic table. If it gives electrons away, we say it has a high metallic character. As you move down and to the left, the metallic character of elements increases. They become more and more likely to give away electrons. So the main group elements in group 1A and 2A have high metallic character. And the nonmetals over here in groups 3A to 8A have low metallic character. They tend to take electrons, except for group 8A, are noble gases. They're inert or non-reactive. An element's physical properties are also determined by its placement on the periodic table. Metals have luster, are good conductors of heat and electricity, and they are malleable. Nonmetals are dull insulators and are brittle. Metalloids, along the bold stair-step line, have mixed physical properties. Let's describe an element on the left-hand side of the table. Take calcium, for example. Calcium has 4 energy shells in its electron cloud because it's in period 4. Calcium also has 2 valence electrons because it's in group 2A, making it a highly reactive element. The elements in group 1A are more reactive, but 2A is still very reactive. We can describe calcium's reactivity further by saying it has a high metallic character. That means that it is to the left side of the periodic table. It is a larger atom that tends to give away its valence electrons in chemical reactions. Because it has 2 valence electrons, calcium is most likely to form a chemical bond with nonmetals from group 6A, like oxygen and sulfur, by giving them its 2 valence electrons. When it does, it becomes a positive ion with a net charge of +2, and the atom in group 6A becomes a negative ion with a net charge of -2. Opposites attract, and an ionic bond is formed. Because it is to the left of the bold stair-step line, we also know that calcium is a metal. That means it is shiny or has luster. It's a good conductor of heat and electricity, and it's malleable or can be flattened into thin sheets. Now let's describe an element on the right-hand side of the table. Take fluorine, for instance. Fluorine has 2 energy shells because it's in period 2. It also has 7 valence electrons because it's in group 7A, making it a highly reactive element, but for different reasons than calcium. Fluorine is reactive because it tends to gain valence electrons in a chemical reaction. It's most likely to react with the elements over here in group 1A, like sodium, because it needs the 1 valence electron that they have. When it gets it, fluorine becomes a negative ion with a net charge of -1, and sodium becomes a positive ion with a net charge of +1. Opposites attract, and an ionic bond is formed. It is on the right-hand side of the table, which means it is a smaller atom and has a very low metallic character. Fluorine is a nonmetal because it's to the right of the bold stair-step line. That means its physical properties are opposite those of metals. If you could freeze it into a solid, it's a gas at room temperature, as are most of the nonmetals, it would be dull and brittle. It's also a poor conductor of heat and electricity. An element's placement on the periodic table says a lot about its physical and chemical properties. The arrangement of the periodic table really is the foundation of the scientific discipline of chemistry. I hope you enjoyed learning about the periodic table and that its arrangement has a new meaning for you. Thanks for watching.